Why do inverse operations work in algebra? Have you ever wondered how we can solve equations so easily? The secret lies in something called inverse operations. These operations are like best friends that help each other out in algebra. They work together to help us isolate variables and find solutions. Let's break it down. Inverse operations are pairs of actions that undo each other. For instance, addition and subtraction are one such pair. If you add a number and then subtract the same number, you end up right back where you started. The same goes for multiplication and division. If you multiply a number and then divide by that same number, you return to the original value. This concept is especially important when we deal with linear equations. A linear equation is an equation that makes a straight line when graphed. To solve these equations, we often need to find the value of an unknown variable. Inverse operations allow us to do just that. Let's look at an example to see how this works in action. Consider the equation for times x minus 3 equals 13. To solve for x, we need to isolate it. First, we can undo the subtraction of 3 by adding 3 to both sides of the equation. So, we write for times x minus 3 plus 3 equals 13 plus 3. This simplifies to for times x equals 16. Now we need to undo the multiplication by 4. We do this by dividing both sides by 4. So, we have for times divided by 4 equals 16 divided by 4. This simplifies to equals 4. In this example, we see how subtraction was undone by addition, and multiplication was undone by division. This step-by-step process shows how inverse operations work in reverse order to help us solve equations. There are also properties that support these operations. The additive inverse states that if you add a number and it's negative, the result is 0. For example, 6 plus negative 6 equals 0. The multiplicative inverse tells us that if you multiply a number by its reciprocal, the result is 1. For instance, 5 times 1/5 equals 1. These properties confirm that inverse operations truly reverse each other's effects. This is why they are so effective in algebra. They allow us to break down complex problems into manageable steps. By using inverse operations, we can tackle equations with confidence and clarity. So, the next time you find yourself solving a linear equation, remember the power of inverse operations. They are the key to isolating variables and finding solutions, making algebra a lot more approachable.